Hi, my name is Mohamad Hamizan from Zaidi. Today I'm going to present my final year project, which is development of Unmanned Space Vehicle. My supervisor name is Encik Mahasan bin Ali. My content of presentation is introduction, literature review, methodology, result, and conclusion. I will start my presentation with introduction. Unmanned space vehicles are operated on the water surface, such as ocean, rivers, and others, for specific purposes. It can reduce risking pilot life during dangerous mission. The example of unmanned space vehicle function are scientific research, environmental monitoring, and military usage. The problem statement of this project are how to design a working prototype of unmanned space vehicle. Next, how to develop unmanned space vehicle which is simple and stable on the water surface. The last one is how to embed multi-purpose function on the unmanned space vehicle itself. As for objective for this project are to design a prototype of an unmanned space vehicle. Next, to develop a prototype of an unmanned space vehicle. Last one is to embed multi-purpose function on unmanned space vehicle itself. There are four main components in the teacher review. The first one is the type of the hull. There are four types of hull, which is rigid inflatable hull, monohull, catamaran, and trimaran. Second is the component of the unmanned space vehicle. The third one is the system in the unmanned space vehicle. The last one, the function of the unmanned space vehicle. In methodology, we start with the flowchart to complete the project. The first step was I figure out the problem statement, objective, and scope. Then I continue with the research on the literature review. Then I did freehand sketching. And if my supervisor approve one of the sketching, I will continue develop it by using SolidWorks. Then I continue with the component selection. And then I proceed with fabrication. And if the components are not suitable, I would go back to do component selection. Then I proceed with programming development after finish fabrication. Then I continue with the prototype testing, and if the prototype testing is not success, I go back to the programming development. That's all for my flowchart. There are three components in mechanical part. The first one is hull, next is thruster, then frame design. The design of the hull is catamaran and the material used is ABS plastic. As for the thruster, I use blue robotic heat transient propeller because it has low voltage consumption, which is around 7 voltage to 20 voltage. And the last one is the frame design need to be rigid, and the material that I use is mild steel. There are four components in unmanned space vehicle. The first one is power system, second is control system, third is navigation system, and the last one is visual system. As for the power system, I use SJ Power Lithium Polymer batteries, which has 10,000 mAh and 22.2 volt specification. We continue with control system. There are three components in control system, which is microcontroller, electronic speed controller, and controller. As for microcontroller, I use PSM. To program the PSM, I use Mission Planner. Next is electronic speed controller. I use Blue Robotic electronic speed controller because it is compatible with the thruster and it can control brushless motor. And the last one is CMK15. CMK15 comes with the controller, receiver, antenna, and HDMI converter. Next, navigation system. I use RadioLink M8 and GPS SE100, which offer 50 centimeters accuracy and positioning 20 satellite in 6 seconds at open ground. The last one is visual system. For visual system, I use GoPro Hero 5 because the camera is waterproof. Now we continue with screening and scoring method in result. This is three sketches that I produced before we proceed to screening method. This is the screening table that I use to evaluate my sketch. The selection criteria are performance, safety, maintenance, attractive, and storage. From the screening table, I decided not to continue to evaluate design A in scoring table. In scoring table, I obtain design C as the highest total score. Therefore, design C is used as the final design. This is the final design of my unmanned space vehicle. I use SolidWorks to draw the final design. Now we continue with controller design. There are 5 components that attach to the piece part. The first one is GPS, Second, safety switch. Third and fourth is electronic speed circuit 1 and electronic speed circuit 2. And the last one is receiver. The component that attached to the piece hop can be programmed through mission planner. The piece hop will obtain power from the power module, and then the power module will receive power from distribution boards that will connect it to the battery. In past development, we need to install mission planner in laptop. Then we need to connect the laptop with piece hop by using micro USB. Then we need to choose COM or auto at the mission planner top right corner. Next, we on the CMK15, which is the controller, by pressing on and off button between A and B with a short and long press once. Then we choose Q ground control at the bottom right corner. The final step for the path development will be we need to on the right switch to start the armor's first vehicle. Then we need to disable the safety switch by pressing the switch to start to control the armor's first vehicle. The last part for the result will be analysis. There are 4 analyses that I've done to the armor's first vehicle, which is buoyancy force, drag and thruster force, power consumption, and FEA analysis. The result that I've obtained from buoyancy force analysis is the force acting on the armor's vehicle and the buoyancy force is equal. Therefore, based on Archimedes' principle, if the object have the same value of force acting on the object and the buoyancy force, the object will float. Thus, by this calculation, it shows that my armor's vehicle can float. Next, in drag and thruster force analysis, I've obtained that drag force is 0.21 Newton, while the thruster force is 12.06 Newton. This shows that the thruster force is much more bigger than drag force. Therefore, my unmanned service vehicle would have no problem to thrust forward easily. In power consumption, I've obtained that the battery can last approximately 1 hour for continuous operation. Now I continue with FEA analysis. I've done a FEA analysis on the frame design. Before we start with the analysis, we need to set a few constraints. The first one is feed support. There are 4 feed support at the frame design, which is the area that connected to the hull. Second, we place the force acting downward at the frame design bar. We place 100 Newton at the bar of the frame design produced by the electronic box load. The last constraint is meshing analysis. I set 5 mm face sizing at the bar of the frame design to get more accurate data. After we set the constraint, we can proceed with the analysis. The first analysis is total deformation. From the analysis, we've obtained that the maximum total deformation would be 0.08 ml. Therefore, it is too small to cause any structural damage to the frame design. The second analysis is elastic strain. From the analysis, I've obtained that the maximum elastic strain would be 0.2 nanometer. Therefore, the value is too small, then we can neglect the value. The last analysis is equivalent stress. The result that I've obtained that the maximum equivalent stress that acting on the bar of the frame design would be 5.9 megapascal. The value is below the elastic yield strength of the mud steel. The elastic yield strength of the mud steel is 250 megapascal. Therefore, it shows that the bar of the frame design won't undergo sudden rupture. Now, let's watch the unmanned space vehicle testing video. We've done the test at the Tasik Taman Aircrew. The test is being done because we need to check whether the unmanned space vehicle can thrust forward easily and steer left and right or not. In the test, we did some calibration to make sure the unmanned space vehicle can thrust forward and steer left and right. From the video, we can see that the unmanned space vehicle visual system is operating perfectly, and the unmanned space vehicle can thrust forward and steer left and right easily. last part of presentation is conclusion. The battery capacity of the unmanned surface vehicle can only last for 1 hour because we can transport the unmanned surface vehicle easily with small battery. If we use the larger battery, it will harden us to carry the battery to go for any testing. Next, there are 6 I/O port available at the PSOC, which means there are 6 components that can embedded to the unmanned surface vehicle. And the last one would be the early development of the unmanned surface vehicle is accomplished. As for future recommendation, I would like to recommend to use renewable energy as the main battery. We can use either photovoltaic panel to obtain solar energy, or we can use turbine to obtain water energy. Second, sonar sensor can detect nearby objects, so the unmanned surface vehicle will not collide with any object. Third, radar sensor can act as the radar of the unmanned surface vehicle, so it can detect in large area. Fourth, ultrasonic sensor can detect echo and depth of the ocean. So if the unmanned surface vehicle can detect abnormal echo below of the ocean, so it can detect any possibility of environmental disasters such as tsunami. The last one is battery size capacity. The capacity of the unmanned space vehicle battery need to be larger, so the unmanned space vehicle can last much more longer during each mission. That's all from me. Thank you for watching my presentation.